Hello there. Today we're going to be talking about the classification of matter. But then more briefly, we're going to be focusing on mixtures. So what are mixtures? So the definition of mixture is a combination of two or more substances where these substances are not joined to each other chemically. So it means that there is no chemical bond or there is no compound being involved in a mixture. So a mixture is basically the combination of two or more substances, but then there is no chemical bonding within a mixture. So here it is. For example, we can take water and sugar. If we're going to mix water and sugar, we're going to get sugar water, and then it's now a mixture. We can mix many things. We can mix sweets and oranges or anything we can mix. That's a mixture. Basically, it says in the name, it's a mixture. So it's a combination, or it's a mixture of two or more substances where these substances are not joined to each other chemically. So in a mixture, the substances that make up the mix are not really in a fixed ratio. So they're not really in a fixed ratio compared to a compound. Remember last time we discussed that the compound, the elements are in a fixed ratio to make a certain compound, but then the mixtures is not in the real ratio. Like for example, if we take a 250 ml beaker of water, it doesn't matter whether you add 20 grams, 40 grams, or 100 grams, or any other mass in sand or of sand to the water. It's still going to be a mixture of sand water. Even if you put 70 kg of sand in water, it's still going to be sand water. If you are going to put 20 kilograms or whatever amount you are going to put in that water, it's still going to be a mixture of sand and water. Therefore, the mixture have got no specific or certain ratio. And then they keep their physical properties. In the example we used of the sand and water, neither of these substances has changed in any way when they're mixed together. Even though the sand in water it's got more amount, is more concentrated in the water. Suppose we put more sand in the water, still it's going to be sand water. So it can be separated by certain mechanisms, physical mechanisms. So there are no processes involved. Remember, we said that they are not mixed chemically, or they're not bonded chemically. Therefore, their physical means which can be used to be able to separate a mixture. So a mixture can be separated by physical means. So which physical means can we use? Maybe filtration. If we're going to mix sand in water and we want to extract that sand away from water, and then we want to drink that water, we have to filter it. We have to filter away that sand. So we can separate by physical means. So we've got types of mixtures. So let's go to types. So what types of mixtures have we got? We've got the heterogeneous and the homogeneous. So we've got the heterogeneous and the homogeneous mixture. So these are all mixtures, but then they've got certain characteristics that make them different. That is why we have to classify mixtures in types. So the first type is called the heterogeneous, and the second is the homogeneous. So exactly what makes us to be able to characterize them that way? So the heterogeneous mixture does not have a definite composition. So by this it means that you can actually see all the elements in it, or in that mixture, not the element, not the chemical elements, but then you can see, if we are going to mix sweets and sand, you can identify that is sand, that is sweets, that is whatever. So it means the certain things that are making that mixture are actually identifiable. You can actually identify them. So think of a pizza. It has got a topping, cheese, tomato, mushrooms, and peppers. You can actually see that this is cheese. You can actually see that this is mushrooms. You can actually see that this is toppings and all that. So that topping is a mixture. So it's a heterogeneous mixture because you can identify. So the components of the heterogeneous mixture are identifiable, or they are not uniform. So components are not uniform. So by uniform, it means that the same. You see, the uniform we use as a uniform to go to school, it means that we want to represent the same thing. Therefore, if something is not uniform, it means it is different. You can see a variety of something when there's a mixture of something. So if you are going to look at the topping of the pizza, you can see the cheese, you can see the mushrooms and all that. Those are not uniform because they are identifiable. They are identifiable with just your physical eyes. You can just see and identify that this is the cheese, there's the mushrooms, this is what and what and what. So they are not uniform. And then this goes contrary to the heterogeneous mixture. Is called the homogeneous mixture. So the homogeneous mixture is just the opposite. The components are in uniform kind of. So what do we mean by uniform? So it means that they are not identifiable. Take it for example, you take sugar and you take water and you mix them together. The sugar dissolves in water and then you wouldn't be able to identify between urine and sugar water because they actually have the same color. You'd be confused on what to drink because they're actually the same color. So the components are not identifiable in a homogeneous mixture. So the components are uniform. So these are the basic types of a mixture. So the heterogeneous mixture is non-uniform mixture, and there are different components of the mixture can be seen and can be identified. And then the homogeneous, it is a uniform mixture, so it means you cannot identify what's in it, because we can take an alloy for an example, which is a homogeneous mixture of two or more elements, at least one of which is a metal, where resulting material has metallic properties. But then we can actually take alloy and you cannot really identify what's in alloy. When you take alloy or you take iron, basic iron, you just say this is iron. You cannot really say there is a certain metal in it, there's a certain thing in it, but then it is mixed by certain things to make the final product, which is the alloy. So alloy is an example of a heterogeneous mixture. Other heterogeneous mixture can involve the mixture of just simple things. You can mix papers, and wood, you can mix papers and pieces of iron fillings or whatever. So those can be identified and can be separated by physical means. Okay, so this is basically what mixtures are all about. Thank you for watching, and I hope you understand. Please stay tuned as we make another video.